Perfect. Let's quickly check how to convert a frustum from a shell part to sheet metal in SolidWorks. Application could be the bottom hopper in a 28-ton cement silo. First, we sketch the offset circles for the 2500 mm upper shell interface and 300 mm exit on two parallel planes spaced 1900 mm apart. Executing standard solid loft, then apply a 6 mm shell command, will hollow it out. Okay, let's start from the very beginning. I'm creating a new part, selecting the top plane, and I will draw a circle here. With the smart dimension, I will set the diameter to 2500 mm. I can also put the units here. Great. Now, parallel to the top plane, I will create another reference geometry plane. I'm entering here 1900 mm, but flip offset to have the smaller circle at the bottom. Even after that is not important. We can change it later. But just to align it with what we decided, I'm doing this. I'm drawing another circle here. With the smart dimension, I'm setting the diameter to 300 mm. Perfect. Now we have two profiles. From the features, I will implement the lofted bus or base command, connecting these two profiles together. Great. We have the lofted object, but there is one point here I would like to emphasize. Make sure that this line showing how much this object is twisted remains within certain degrees. 1 or 2 or couple of degrees is okay, but if it's too much, for example, it's twisted that much, then we will face the problem once we are converting this part to sheet metal. So we should make sure that this line is not twisted too much. So 1 or half a degree should be okay. Now we have the frustum as a part. I'm making this as a hollow object by removing the material. The thickness will be 6 mm. I'm entering here and I'm removing the upper and lower faces. Great. Now we have the object. Let's allocate some material to that. I'm selecting the ASTM A36 steel. That is closest material to ST37, the material that I am using in my production. I'm also changing the color here. Let's change the color to light blue to make it align with the cement silo that we have designed. And you can find it in our long videos in my YouTube channel. Now I'm saving this somewhere. Let's just give a name to that. Perfect. So far we have a shell part. Now we are ready to convert this to sheet metal object. To do so, first we need to cut it here on a slant. To do that, I'm generating one center line first on the upper rim. And you see that the center line I'm just drawing from the center to the outer rim to have a cross section here. This point is important for me. This rim is important for me. Good. Now I'm going to the tab sheet metal and I'm selecting the rib. With the rib, I can create the slot here, selecting this outer rim and then selecting this crossing point. Perfect. You can see the preview of the slot. Let's set it to the symmetric. If you follow my mouse, you can see here other settings. Let's put other parameters also to the right numbers. I'm putting 1.5 millimeter here, equal to the welding root gap. Perfect. Everything is set now. Great. I have now the number and I will implement the insert bend. To do that, I'm selecting this edge. Good. It's done. Now you can see in the design tree that the object is converted to the sheet metal. It's not object anymore. It's sheet metal. And by moving on the tree and suppressing or unsuppressing the commands, we can see the object in a folded or in an unfolded shape. So here we can see this object in an unfolded shape. And if I move here on design tree, I can see it in a folded shape. Perfect. That's all. That's done. I'm again updating the save. Let's turn off these and hide them. Okay, good. So here we have now one frustum with the similar dimensions equal to the bottom hopper of a 28-ton cement silo and already converted to sheet metal, ready for implementing the details of welding, for example, here. These are the things that we will see in next videos. Thanks a lot for watching this video and following me in these short episodes. Bye bye.